Today we are going to discuss an incredible concept, the space elevator. Imagine riding an elevator, not just to the top of a skyscraper, but all the way into space. In this video, we'll explore how a space elevator could work, the mind-blowing technology that might make it possible, and the challenges scientists and engineers face. We'll look at where on Earth this marvel could be built, and why its location is so important for success. You'll discover the revolutionary materials, like carbon nanotubes, that could turn science fiction into science fact. And most importantly, we'll see how the space elevator could change the future, making space travel routine, opening new frontiers, and inspiring the next generation of explorers. So buckle up, because the journey to the stars might start with a simple elevator ride. Let's get started. How do you build a structure that reaches space? The answer, a super strong tether stretching from Earth's surface to a counterweight in geostationary orbit. At this altitude, the counterweight orbits in sync with Earth's rotation, keeping the tether taut, like spinning a ball on a string. The outward pull of the counterweight balances gravity, stabilizing the entire structure. Robotic or crewed climbers attach to the tether and ascend using electric power, beamed up from the ground by lasers or microwaves. Multiple climbers could travel simultaneously, creating a steady flow of traffic between Earth and orbit. The system's center of mass must stay in geostationary orbit, so as climbers move, the counterweight or other climbers adjust to maintain balance. The base would likely be a mobile ocean platform near the equator, able to dodge storms and debris. This setup makes the space elevator far more efficient than rockets. No single-use launches, just continuous, gentle transport. It's a delicate dance of physics, engineering, and orbital mechanics. The result? A permanent, energy-efficient highway to space. The space elevator could transform how we access and use space, making it routine and sustainable. The biggest challenge? The tether's material. Steel, titanium, even Kevlar, all too weak for the job. Enter carbon nanotubes, cylinders of carbon atoms, rolled from graphene with astonishing strength and lightness. Pound for pound, they're up to 100 times stronger than steel and 6 times lighter. The perfect combination for a space elevator. Their strength comes from powerful atomic bonds, making them ideal for a cable stretching from Earth to orbit. Carbon nanotubes also conduct electricity and heat, useful for powering climbers and managing temperatures in space. The catch? We can only make nanotubes a few centimeters long, nowhere near the thousands of kilometers needed. Scientists are racing to scale up production, weaving flawless, continuous ribbons from these microscopic tubes. Solving this material puzzle is the single most important step to making the space elevator real. With the right breakthrough, the impossible becomes possible. Carbon nanotubes are the key to turning this dream into reality. The anchor station must be near the equator, directly beneath geostationary orbit, to keep the tether stable. An ocean platform is ideal, mobile, able to avoid storms, and far from busy shipping lanes or populated areas. Weather is a major threat. The lower tether faces high winds and lightning, so advanced protection systems are essential. The equatorial Pacific or Atlantic offers vast, open, and relatively calm regions for construction. Lightning is a real danger. A conductive tether could attract powerful strikes, so the anchor must safely dissipate energy. Political stability matters too. The site should be in international waters, free from disputes and accessible for construction. Finding the perfect spot is a complex puzzle, balancing geography, weather, safety, and politics. But securing the right location is a crucial first step. The right site will set the stage for this engineering marvel. The journey to a full-scale space elevator has already begun, with researchers and companies tackling the toughest challenges. The focus developing super-strong tether materials and designing robotic climbers. NASA's space elevator games spurred innovation, proving laser-powered climbers can work on Earth. In 2018, Japan's STARS-ME experiment sent a tiny climber between 2 satellites in space, a small but vital proof of concept. The biggest hurdle remains, manufacturing long, flawless carbon nanotubes or similar materials. Companies like Obayashi aim for a working elevator by 2050, investing in research and development. These aren't just dreams, they're real projects, backed by engineering and science. Each breakthrough brings us closer to making the space elevator a reality. The future is being built in labs and workshops right now. The space elevator isn't just a new way to reach orbit, it's a leap in how we see our place in the universe. Rockets open space to a few. The elevator could open it to all, making space an extension of Earth. Building it will demand global cooperation, innovation, and bold thinking. Imagine solar satellites beaming clean energy to Earth, or Mars missions assembled in orbit. This is the future the elevator could unlock. It's a call to the next generation, scientists, engineers, artists, and dreamers. Learn, share, and get involved. The journey needs all of us. Every great achievement began as an impossible idea. The space elevator is our era's great challenge and opportunity. Let's support the science, inspire each other, and build the stairway to the stars. The future isn't something we wait for. It's something we create together. The dream of a space elevator is bigger than any one person. It's a vision for humanity's future. If you're inspired by what's possible, help us spread the word. Hit that like button, subscribe for more journeys beyond the horizon, and share this video with fellow explorers. Every click brings us closer to turning science fiction into reality. Together, let's keep reaching for the stars, one idea, one action, and one community at a time.